for alpha particles as per the O-level physics syllabus. So it can be used for the detection of any radioactive particle, alpha particle, beta particle. Just for our syllabus, we'll refer this device whenever we have to detect the presence of the alpha particles. Then you have a bit of the explanation. You need to just go through it, and how it works is, so you have this place, and this space is filled with vapors. So you can enclose this place like in glass jar, and that should be including some gas vapors or water vapors as well. A piston expands, the gas in the chamber is cooled, and the temperature falls below the condensation point of the vapor. So when you expand the piston, the temperature of the gas would drop because the pressure would decrease. If it contracts, then the pressure, it would create the pressure would increase. But otherwise, in this case, the pressure would decrease. And hence the temperature of the vapor, of the gas, would also drop. And it would fall below the condensation point, by which the gas particles or the gas molecules would be condensed. Then the next pointer, the charged particles or energetic photons passing through the chamber collide with gas molecules. So you have the radioactive source placed over here. Here you have the radioactive source, and this is just a shield. Okay, we are just shielding the radioactive source so that no radioactive rays should be emitted on any other side. They should be directed straight towards the cloud chamber. So as they enter the cloud chamber, they collide with the gas molecules and ions would be produced. And hence these condensation forms along the path of the nuclear radiations. So wherever the region or the tracks where you have these radioactive particles or rays, these condensed vapors would be formed. So this is how we detect the radioactive rays or particles. So if they ask you for 2 marks, which generally they can ask you for 2 marks. By the way, this is the newly added topic in your syllabus, and the questions that we have from this topic are basically from IGCSE and GCSE. So in those papers, the question they can ask you is, how do we detect the radioactive particles using the cloud chamber? So out of these 4 points, you can narrow them down, or you can write all of them as it is if they ask you for 2 or more marks. Now the next thing is, using the cloud chamber, how do we identify the radiations or the particles? How do we say, okay, these ones are the alpha particles, and these are the tracks for the beta particles, and these are the tracks for the gamma rays? For the alpha particles, bit of theory, you need to have the prerequisite, which is the nature of the alpha particle and some of their properties. For example, alpha particles are relatively heavy and they have positive charged particles. They are positively charged particles. They have the highest mass comparatively. So when the alpha particle pass through the cloud chamber, they create dense, short, and highly ionized track. Why dense? Because they have high mass. Why short? Because they have less penetrating power. They don't travel that much. They have very small range. So they create the track which is short, dense, and highly ionized, like it's very much visible. So these tracks are thicker and less extended compared to the ones produced by beta or gamma particles. So what we write here is this thing. All right, now you should be able to classify or explain each word here. For example, every word here. For example, why do they create dense track? Because they have high mass. They have, matter of fact, they have the highest mass comparatively. Why do they create short track? Because they don't have much range. They have less penetrating power. They start ionizing. They have high ionization ability, but at the same time, they have less penetrating power. And why they create highly ionized track? Once again, because uh, they are dense, they have more mass, they have more charge, they are positively charged. And you can extend the same thing uh, as alright. So alpha particles, when they pass through the cloud chamber, they create the dense, short, and highly ionized track. Because they have more mass, that's why they create dense. Because they have less range, they have less penetrating ability, so they create short tracks, and the tracks are thicker and less extended in comparison. So the tracks that would be less extended and thicker, more visible, would correspond to the tracks of the alpha particles. So we can say, okay, so we have the alpha particles over to that side. All right. For the gamma rays now. So gamma rays are the electromagnetic radiations and they carry no charge. In principle, the gamma rays are uncharged. So when they pass through the cloud chamber, they do not ionize the surrounding vapors like alpha or beta particles do. Therefore, the gamma rays do not leave any visible tracks in the cloud chamber. As they would not ionize the gas. And we study that in properties as well. If you remember the characteristic table, we studied in that the gamma rays, they have the lowest ionizing ability. So the other thing is, in the cloud chamber, they do not leave any visible track. However, they can produce some extra effect, some secondary effect. For example, the photoelectric interactions and also Compton scattering. But these are the processes or the stuff that we study in higher level physics. So at this stage, what we say is gamma rays, they do not leave any track. So what do we do with the gamma rays? Well, we identify gamma rays indirectly by observing their effects on other particles or by using some other detectors, for example, the GM tube, that can be used along with the cloud chamber. Then we can detect the gamma rays, or you can use the GM tube separately, then you can detect the gamma rays. And the other thing, you can study the effect of these gamma rays on some other particles. For example, photoelectric interaction, Compton scattering, but this is for higher level physics. Cloud chamber, it can be used to detect and distinguish between alpha, beta, and gamma rays. How? By analyzing the characteristics of the tracks that they leave. So alpha particle create short, dense, and highly ionized track. Beta particles produce thinner, less dense track, and gamma rays do not produce any visible track in the chamber. So for the gamma rays, we'll need some additional detector as well.